what is the essential? So what is the essential part? Okay. So what is the essential part of the code? Okay. So and what does these mean? These look like LaTeX, you know. So anyway, so here, so basically, what happens is we're going to learn how PyTorch implemented and how PyTorch implements an optimizer. So, and we'll learn like a class and object-oriented program in this class. Okay. So this is hopefully we'll finish. If we can finish, we'll come back next Tuesday. And then we'll have our next coding homework. And then after this coding homework, we'll start our final project. So it will be on Kaggle, and hopefully, so okay. So it's a good time to, if you haven't had an account, okay, on this website, it's a good time that, for example, you come back to this website. So for example, this website is pretty cool. It has competitions. So we'll have our competition, but it's in-class competition. For example, in this competition, it's using machine learning model that predicts the structure of an RNA molecule.
They're paying that money to the winner? They're paying that money to the winner?
It's shared by like by the top 5, I believe. Yeah. Yeah, it's you can think in this way. I participated the Stanford University's competition 2 years ago, so it's a similar thing. So I basically I code some. Yeah, this one. It's also by Stanford University. It's the same thing. I mean, so what happens is they like a crowdsource to public, you know. So, for example, they set up a grant and they pays the winner, you know, the students, like $100,000 for a good model. I think we didn't win, but so so this guy was my student back in University of California, and we got silver medal. And these two students, unfortunately, they don't participate anymore on Kaggle, but they are students in University of Georgia. So now in University of Georgia. But they were my student, and I wrote some like sample code. For example, you can see your work, you know. So for example, I wrote some base code and they modify it, you know. So anyway, so Kaggle is basically machine learning like a competition platform. So we'll have our in-class competition, you know. So we got 10-form team on Canvas. And so there are lots of fun competition, but so the goal of this class is after you take this class, you will be able to tackle one of these competitions by yourself. You know, you'll be able to read the code. You're able to read other people's code. So basically, so for example, if we navigate through, we'll find, and if we sort by maybe highest votes, okay. So they have lots of code, right? So for example, this RNA starter, okay. So it's a notebook style, same thing, okay. Yeah, it explains things, but you see, it got lots of these. So this is a class, by the way. You see. So the goal of our class is to be able to read other people's code. For example. What is this double underscore mean, you know, in Python convention? And okay, so this is our goal. I mean, our goal is always being able to read other people's code. It's never write code by ourselves. I mean, it's good that because I was trained like 20 years ago to write a whole chunk of several couple thousand lines of code to implement something, but I don't think it's suitable for today because I don't even go back to find, for example, especially considering you have this, you know. So for example, you know, so even auto complete the question for me. I mean, you have to sign in, ask questions, but it generates, you know. So why should I? But this is wrong though. So I mean, this is not a let me say this is not a complete answer. Okay, so yeah, but this is not a complete answer. Okay, yeah. So this is better, but this is not a complete answer. Okay, so my point is so the training needs to be changed to incorporate the newest tools that will be able to use these tools to help our research and maybe looking for a job, you know. So so this is today, maybe next Tuesday's schedule. So we'll learn class and we'll learn a simple neural network. So we won't go into detail of how like the mathematics of neural network. But the coding lecture is basically we'll be able to use this class, okay? And then we'll learn this try except flow control, and we'll have a training pipeline template. So template programming. Oops. So having a template is very important. Okay. So having this template is very important. For the programming. So before the era of this large language model, I still keep lots of template for all my numerical recipes, like categorized. For example, Newton, you know, quasi-Newton, inexact Newton. So I have this in the central GitHub repository that I maintain like a private by myself. You know, have all these routines, and so I can, you know, if I forget something and I want to refer to a template, I can just copy and paste. So it's a good habit to maintain such a thing that we collect. For example, the code you think is helpful for your future research or looking for a job, you know. So and then we'll learn some data loader interface and new type of variables. Let me add this. A new variable type. Okay, it's called dictionary. It's pretty helpful in Python. Okay, I like this a lot. So it simplifies a lot, especially considering I was trained back in C++. You need to write all these. You know, I don't know what the sign called, but its name is pointer. You need to point to the right thing in the memory to load things, but with Python it's just a dictionary, so it's pretty handy. So let's review this iteration. Okay. So in Python there is some object called an iterator. What does iterator means is we can iterate on. Okay. So the programming 101 normally just say, okay, so for I in range. Let's say 10, let's say 5. Okay, so for example, this will print, you know, from 0 to 4, right? It has to stop. Okay. So this is what our traditional training gives us. All right. This is what our traditional training is. The for loop. Okay. The for, and this I is indices. But in Python, there is some iterator. So for example, as long as we can iterate using for loop in this, it's an iterator. So for example, we can create some called for example, let's create a list. List 1, okay? We can do apple. You know, like pear. I don't know, kiwi. I'm just making things up, you know. So traditional way of accessing, okay, this list is for I in, range. What is a range? So the index is like the length, okay, of. Yeah, let me make this bigger. How about this? Yeah, this is better. Okay. All right. So for example, range len list 1, okay, and then we print list 1's ith entry. Okay, so this is the most traditional. I mean, this is the most traditional way of doing things. So accessing the elements of a thing. But in Python, we can iterate. Once we can iterate, okay, something, what we can do here is for, okay, for, I don't know, maybe let's give you in list 1. And you, okay. Yeah, let me, if this is not clear, let's split it. Oh, what's what's the keyboard shortcut? I forget. Okay, so let's try this first, and then, I mean, it's the same thing. So this thing here is called this is something iterable, okay? And if we want to make it to be an iterator, okay? So if we want to make something an iterator, so this now is the most efficient thing in Python. Is, people always question Python's efficiency, but I don't think those people know how to leverage the power of Python since Python 3. So Python 3 introduced something called iterator. Okay, so what it does is, so this iterator is powered by some thing called iter. So as we can see, so this thing changes color, in your editor. So it's a built-in function. Okay, it changes something to an iterator. For example, list 1. And now let's print. So let's first, for example, print. So let's print type of list 1. So type of list 1, it should be type of list 1 should be a list. Okay. So it's a list. It's now even in Python. What's the version of Python? But anyway, so normally it's just print list, but list is a class though. Anyway, so it's a list, right? So now let's print this type again. Okay, it will tell you if it's still the behavior of Python 3.8, it will tell you that this is an object in memory, blah blah blah. Oh, it tells you this. Yeah, I guess it's normal. Okay, so let's print st2. Oh yeah, here. Okay. So this will tell us. Okay. So if we print this guy, if we print this guy. Okay, so let's try this again. So it will just print how do I say it? All the items in this list, okay? And this actually has a drawback, okay? The drawback is all the items of this list is now loaded into the memory, okay? I mean, we have a limited amount of memory, and for example, in training large machine learning model, we have limited memory, especially considering if we're using GPU. the largest single GPU has only like 80 gigabytes of memory, and for example, I train some medical imaging model, and even with 4 images per batch, and it fills the memory pretty fast. So my point is, we can load all the data to the memory. So what iterator does, okay? Thank you very much. So what iterator does instead is, so an iterator, is a generator. So it doesn't load everything. So it does not load all the items to the memory, to the main memory, I would say. So instead, when we want to access it, okay, but we can still use the for loop. So you will see. So for example, for B in LSD2, okay, print B. So it's still, this behavior is the same, okay. But instead, for an iterator, so the items is loaded into memory one at a time. Okay, so we can. So for example, what we can try another test is, so this next command. So for example, we can do f equals next LSD2, and let's print f. Okay. It's basically adding. So it's stopped. Okay. So because as we can see, LSD2 is already like accessed into the memory, and the next will give us nothing. So if we do this again, so next is fine. Okay. So it's apple, right? So now if we do this again, we'll only have this. Okay. So this is how iterator kind of work, but iterator is pretty used everywhere in machine learning because the data size is just too big. It cannot be loaded into memory at one time. So we have to use this iterator or generator, to load items into memory on demand. Okay. So the second, the second most common used thing in class, in machine learning is object-oriented programming. So this is a class. Okay. So I mean, in general, the most common, function. So let's say, so for example, if we want to define a function, so this is the syntax of a function. The function has input, and the function has an output. For example, we can do this. Okay, so the input is x, output is that. So if we do something like, so for example, this is computing x squared. So for example, if we print func, 3.14, so we'll get we'll get its square. Okay. So but class is something different. All right. So class is something different in general. So okay. So the syntax is still kind of the same. So don't forget the comma. So sorry, column. Okay. And then we can set up. Okay. So we can set up, for example, I don't know. Let's just do, for example, yeah, let's try, I don't know. Okay. So, what is a good example? For example, you see sometimes. Okay, so let's do class CS. you know. So for example, we can do name equals, for example, CS 5590, and auto name is math 5555. Okay. So then what happens is, so now we have a class, okay, and we can initialize this class. So right now this class is not defined yet, okay. So what you can do is you can do CS, I don't know, so you can do C equals CS, okay. And once you have do that, C is, so for example, if we print, the type of C is going to be a class now, okay. So now what happens is we can access, for example, its name. All right. So as we can see, so and this is the dot thing. Okay. So these are called the attribute of this class. Okay. So this is how to access to attributes. And so this is perhaps the most simple example of class. And we can add more. So for example, you can add other things. So like time equals something, you know. So time equals 8:30, and you can even load a function here. So for example, import time. You know, you can even do this. So basically, within this class, you can do whatever you like. But there is some tradition, as you can see. Python does not give me any error. Okay, but there is a tradition to define a class. Okay. So the first line you'll see is normally define, initialize this thing, and you have this double underscore. So in Python, okay, this double underscore so this type of thing is the Python tradition of built-in function. All right. So it just means like it's like a standard template in C++. Okay. So for example, this part is called a constructor. So the below, so init function is a constructor. What it does is it's like it reads as literal, so it initializes this class, but constructor just means we construct this class. So the first input is always self. So self refers to the class itself. Okay. So what happens is if we have this self, we can use self later. So we'll see how this works. For example, if we want to, for example, this is a class vector. Okay. So this vector, like 2D vector, we have two components, and these are the input. Okay. So if we have access to self, what we do is self.x equals this one, and self.y equals this one. So this is like the this is a, so even though if we read the Python class for the first time, we will think this self is weird, but it kind of conforms with the tradition of a function. Okay, so what's inside the function must be defined within this function. Okay, otherwise even though people, people with bad coding habit will do something like this, y equals 1, and then it loads, x equals x plus y. This is okay. I mean, this is totally okay. Okay.
Yeah, but that is global defined, right? Globally, we are defining it. That is out. If we define outside the
outside the function is fine. So define outside the function is fine. So this one normally is called a global variable. So this should be avoided in the programming because in general, okay, because there are global variables. Yeah. So this will run. I mean, this will run. So this will run. But this is this is very bad coding habit. So we should avoid it. I mean, so this is the way to go. Okay. But anyway, so my point is, if we wanna, for example, if we wanna use a variable, the most common way is do this. If we want to add input. So the syntax here is kind of the same. If we want to access to an object within the function, we have to use this object as the input of the function. So the self refers to this class itself. Okay. And now we set this. So let's run this class. So let's run this first. Then we'll explain what happens down here. Okay. So now this is a class. So how do we initialize the class is, so let's try this first. Okay. So let's try v equals vector. All right. So if we have a function, right? If we have a function and the class is the same thing, the class has to do this. Okay. So now let's try this first. Okay, it will give us error. All right. So it says the vector. So if we have this constructor function defined, if we have this constructor, this initialization defined, once we initialize a class, it always tries to find here, okay? So for example, so as we can see, the self refers to the self, okay? But we need to give these two input to the class. So for example, so now the type error is vector init missing two required positional argument, this and that. So just continuing the conversation, that I think the biggest, or say the most important capability to coding is to read other people's code. The other one is read the error message. Okay. So this gives us this error message, right? So how do we fix it? So for example, if we do vector, so Colab will actually tell you, okay, so here, yeah, right here. So it tells you that we need this input. Okay, now we can give it maybe say 1.5, and then, okay, once we put a comma here, it tells you, oh, you need to do this, okay. For example, so now we're good. If we initialize it, we can access. So after this line is run, the constructor init function has been run. What does that mean is actually these two lines are run. And this self refers to the class itself, okay, which is this v. So now we can access to vx and y. So print vx and vy, and we'll get 1.5 and 6, right? Okay, so all right. So now let's look at this class. Is we can define several. So as we can see, so the indentation. So Python has something called indentation. So this class has this indentation, right? But now this definition, okay, this definition, this def just means we define a function, has also this indentation. So once it's indented under this class, it's like, so this is what we call a method in this class. So a method just means a function. I don't know why it's called a method. Yeah, it's just a function. Okay, so it's a function in this class. So if we want to access to this function, then we want to always put a self. Yeah, okay. So if we want to add access to the self x, self y, okay, then we always want to do like this. All right. So for example, what this does is, if we have another vector in this class vector, is how do we add these two up? Okay. So for example, so let's try to rationalize this add function using example. So now if we have another vector, let's say u. So I don't know. Maybe say this is 2, this is 1, okay? So now this is a vector of 2, 1, right? So okay. And we want to add them up. So let's run this. Okay. Let's don't run this first. So we want to add these two vectors up, okay? I mean the most common thinking is u plus v, okay? But unfortunately Python will give us error. Yeah. Oh, it's good. So why? I see. Okay, never mind. Yeah. So this class has been. Okay, let me run this again. Okay, so, because this was already in the memory, okay, so I forgot to change it here, so let's rerun. And we'll explain what this function does. As we can see, once we add this function, the add sign is okay. So we want to add two vectors, right? We want to add two vectors. We initialize this vector, okay, to be 1.5 and 6. Its x component is 1.5, y component is 6, and same thing here, x component is 2, y component is 1, and we add them up. Okay, so unsupported operand type for plus vector and vector. The reason is because the error message, okay, so the operand plus is not defined for this vector class. This customizedly defined class, okay, vector, has no function.
Is it because they are in the like class type they cannot add up to each other? I mean, like outside this class they can like add up to each other, right?
So
and just like you just run it the first time and they added up because like they were not in the.
okay, to answer this question, we have to go through Python. So Python has add. So let's give this example. Okay, so the add operator. Okay, so why we call Python object-oriented programming is, for example, the plus. Plus is just like we treat plus like we add two things, right? 1 plus 2. But the plus behavior is different for Python. For example, if we have two lists. I'm just making numbers up. What does this thing do?
I think just put all their A's.
Okay. So I mean, for someone who familiar with MATLAB, we may think this is 54 and 112, right? But the answer is, unfortunately, I mean, because I asked this question, you guys already know this. The question to this is different, right? So for list, actually plus behavior is concatenating these two lists together, okay? So, for example, now if we do ARR, okay? So for example, torch, I don't know, torch tensor, 2, you know, do the same thing. So let's just do AR2 equals torch tensor. Okay. So now if we plus these two, I forgot to put torch. Oh, I did. Okay. Yeah, let's do it on the first. So now if we try this again, now it becomes that, right? So we can see the output is now 54 and 1012. So the point to make is plus. So my point is the plus. So the lesson learned from this example, so plus is defined by user, you know, or by the package designer. And its behavior is different for different objects. Okay? So the same thing here. This is actually when we initialize this this class, the add is not defined. So one way to add is we define a function, okay, like this. So this is the add function. So how to call this function is, so let's add a code here. So because this function is defined within this class, how do we access this function is we can just use u dot. Okay, so it's already here. So once we put dot, it has this auto completion. All right. So we hit tab and it's add, right? And then, you know, so it's a vector. So there is some there is some actually some Python syntax. So we can give something like this, okay. But let's try not to do this. So this is called like typing, but it's kind of advanced technique. So we can do this. All right. This is fine. So as we can see, u is what 1.56. Sorry, u is 2.1 and v is 1.56, and we add them up together, right? So this is one way. And for example, we can do v add u, so it's fine as well. Okay. So if we want to do, so now let's copy paste. Let's copy paste this vector. So let's delete this just to make things less confusing. And so let's add a code here. Yeah. Okay. So we have this, right? Everything is the same except we add this function. So what happens is this double underscore again. So the double underscore means built-in function. So if this is a Python tradition for built-in function, okay. So this actually defines. Yeah. Okay. So already here, define plus behavior for this class. So we run this. Yeah. Let's don't overwrote. Okay. So I don't want to do this. So let's rerun this. So. Okay. And now let's name this vector a new vector. So let's do new. And let's delete these things. Okay. Okay. So let's run this again. And now let's initialize. So for example, u equals vector new. Let's do 1.5, which is x coords. So y coords is 2. So v equals vector new 3, 5. And now we print u and u plus v. They are good, you know. So it's 4.57. Okay. Now here we have another question. So so for example, so you guys may want to try. So let's say if we print this most likely will print a list. Okay. No. So like I said. So if we print u is 1.5, a 2, right? But instead it prints this thing here. Okay. So how do we improve it? So the idea is so let's do new. Okay. So the tradition of class naming is using the camel case. It's like every word, the initial is capitalized, there is no space. And as we can define a new function called representation. Okay, so as we can see, Python already autocomplete for us. So, okay. Oh, it's pretty cool. So it tells me this should return a string. Okay, this should return a string. But let's just not confuse with this syntax. Let's delete this. Okay. So what happens is let's return. Okay. So a string is normally use this double quotation. So return, and let's use f string here. So what we can do is f string is basically we can use this curly braces to insert things. Okay. So for example, okay, so we can do this. So keep in mind that this gives us something like this, right? So print. So what printer does is it just print the string in this representation. Otherwise, it's just print the memory location of this object. Okay, so now let's do it again. Let's try. So u equals, so vector new, okay, 1.5, 2. And now let's print u. Oh, it's not defined? I haven't run this. Oh, sorry. So as you can see, it prints something like this. We can actually change it. For example, if you like to change it, it's something like this. So once we run this, this will become this this angle bracket, you know. Okay. So it changes the print behavior. I mean, so this double underscore is just like a default function, you know. Sorry, the built-in function of Python tradition. So you can change. So for some class, this is predefined. For some class, we have to define these ourselves. Okay. So this is about class. So class is used everywhere in PyTorch or in general in machine learning research, you know. So I load here. So the pipeline A proper pipeline consists, so we prepare the data, okay, and this may be taught in the machine learning class. So, and then we choose a model, and we choose an optimizer, or write one on our own. We choose a scheduler or write one on our own. So this is optional, so it will be in the starter code of the final project. And we choose a proper, what we call the loss function. It's basically a function we want to minimize. Okay. There are lots of built-in functions. The train is basically the iterative method we learn that, we find a point that is better. So, okay, so now let's do it. So let's download the data. Okay. So we just download the data. So if we want to, so for example, in Colab you can browse the data here. Okay. So for example, if I download the data set MNIST, so MNIST will be here. So it will be in this kind of raw form. UByte just means 8, UByte just means we use 8-bit. This type of thing is so every entry of this is 8-bit, and when we transform to tensor means now it's in PyTorch tensor. So for example, so if we print this train, it will tell us, okay, so it's the data set MNIST, So it's a class, by the way. So for example, we print train. Maybe let's print the type of train. So it's a class data set. So it's class. It's a class. Yeah, let's add a new line here. So as we can see, so the type of this train is basically the Torch Vision dataset MNIST class. Okay, and it has these methods. So if we want to know what methods this thing has, this class has, we can use dir. So for example, in the train. So these are the methods. So for example, we can see first the built-in method, right? The built-in method is add, annotations, class get item, so dict, and this is dictionary. Hopefully, I don't think we have time to learn it, but this class, but we'll do it next time. Okay. So these are some built-in functions, and it also has like the user-defined function, for example, without the double underscore. So we have these many functions, for example, transforms and etc. Okay. And some of these are not functions, are just attribute. So for example, so let's recall here. Where is it? Okay. So for example, if we access, so this is a function in this class, this add, and this dot x is just an attribute of the variable. Okay, so for example, this is access the attribute of this variable, and this is add. Let me see, where is it? Oh yeah, this is accessing the function associated with this class. Okay, so now let's scroll down. And let's prepare the data. So we've done this in the homework too. Okay. So the data loader is a very helpful function. It's a very helpful class. It just converts this data to an iterator. Okay. So. It's a data loader type, so now its type is a data loader, but now it's an iterator, okay? So it's a data loader. What happens is, So it's a generator, and we use eta to make it an iterator, okay? And then so this guy, what happens is this loader basically doesn't load everything into memory. So unless we run a for loop on it, it's not loaded in the memory. So for example, if we do this, we will get a sample, okay? So for example, if we do this, so first of all, if we print this sample, so let's print sample size first, okay? Yeah, I think this is, let's do this first. Okay? So let's do this first. If we print this, we'll get an M batch, which is 64. So the batch size is 64. And list object has no attribute size, right? Oh yeah. Sorry. So it's mnist. My bad. Yeah. So it has to be 0. This is correct. Okay. So as we can see, okay. So this is like this is the train data. So sample is in the sample is a list. Like in this following form, okay. So x is called basically the data. So x is the data, and y is called the label. So as we can see here, so it has 64, and here is we have one channel. One channel just means it's a grayscale image, so you can think it's like a black and white image. And this is the resolution we have is 28 by 28. So so each image is represented by a 28 by 28 matrix. Okay. So now we do this. So let's try this first. So for example, this will just be like 64. So it's a label. So if we print it, if we print the first 10, it will give us like some number from 0 to 9. Okay. Because it's handwritten digit, so it tells us what are these digits. Okay. So maybe let's just stop here. Let's continue this next time. So yeah. So let's stop here. Let's continue this neural network thing next time. Okay.
Thank you, sir.
So I'll post. So our homework will then be posted after next class.